These two Anritsu signal analyzer models cover different measurement needs. The high-end MS2830A is based on a high-performance spectrum analyzer for the 31.25 MHz analysis bandwidth and has a built-in signal analyzer. It's the perfect combination of performance and functions for R&D. The middle-rank MS2830A has a wider range of general applications using a simple spectrum analyzer in combination with the signal analyzer. The base MS2830A platform is the spectrum analyzer. Adding the optional FFT analysis function turns the MS2830A into a signal analyzer supporting transmitter characteristics tests. Adding the optional vector signal generator allows for the output of reference signals for parts evaluation. Both modulated and continuous waves can be output. The low-cost MS2830A spectrum analyzer supports mid-range performance requirements. The standard spectrum analyzer functions support all measurements for testing transmitter characteristics. The ACLR function sets parameters by selecting templates. In addition, changing in-band channels from 1 to 12 is instantaneous. The spurious function divides the measuring frequency range into a maximum of 20 segments and sets each spectrum analyzer parameter and limit line. It supports continuous automatic measurements for 20 segments and displays each peak value. The spectrum mask function sets parameters and limit lines for a maximum of 6 segments symmetrically on each side of the center frequency. Support for both absolute and reference level measurements is fully standards compliant. The occupied bandwidth function parameters are set by selecting standards templates. The N% and XdB measurements are fully standards compliant. The channel power function measures power in the specified frequency bandwidth. Rectangular, Nyquist, and root Nyquist filters are supported. The burst average power function measures power between two markers. It's convenient for measuring the power of burst on and burst off signals. The multi and zone marker function places up to 10 markers at any location. The marker width may be either spot or zone. When measuring peak power with a zone marker, peaks in the range are detected automatically, ensuring that all peaks are measured even when there is some slight frequency fluctuation. In addition, the powers of up to 10 points are displayed as a list. The frequency counter function measures CW signals. It supports high-accuracy frequency measurements under 1 Hz. Adding options to the MS2830A spectrum analyzer platform turns it into a high-performance signal analyzer. The signal analyzer supports FFT analysis of signals in a specified analysis bandwidth and displays 5 trace screens. The spectrum function continuously captures and displays signals in the set bandwidth for the set time. It can be used to simultaneously check spectrums that cannot be checked with a conventional suite-type spectrum analyzer. It's ideal for checking transient fluctuations and burst signal rise and/or fall times. The frequency versus time display confirms frequency changes using a graph with frequency on the vertical axis and time on the horizontal. It can be used to measure the frequency shift of FM signals. The amplitude versus time display confirms changes in amplitude using a graph with amplitude on the vertical axis and time on the horizontal. It can be used to check level fluctuations of burst signals in the time domain. Another function of the amplitude versus time display is measuring the modulation of AM signals. The CCDF display indicates the cumulative distribution of transient power variations compared to average power. By comparing with a Gaussian trace, it's possible to save the CCDF waveform as a reference for comparison. The APD display indicates the probability distribution of transient power fluctuations compared to average power. The spectrogram displays levels in different colors on a graph with frequency on the vertical axis and time on the horizontal. It's a key function for finding points with transient fluctuations. Additionally, it can also be used for hopping and chirping signals. Adding measurement software to the signal analyzer supports EVM and constellation measurements. The MS2830A supports all major wireless communication systems. Installing each software license supports modulation analysis. RF signals are captured to internal memory. Even transient signals that cannot be observed with a conventional sweep-type spectrum analyzer are captured, so nothing is missed. Captured signals are saved to hard disk for replay to confirm trace signals at any time. A built-in vector signal generator can be added as an option to the MS2830A spectrum and signal analyzer functions. It has the same performance, including level accuracy and RF bandwidth, as a general-purpose vector signal generator. The vector signal generator function is based on arbitrary waveform memory with pre-installed general wireless communications waveform patterns. In addition, it has an AWGN generator option for measurements with different carrier-to-noise ratios. The vector signal generator has an optional AWGN generator to output desired waveforms with added AWGN at any level. The vector signal generator waveform patterns are saved in the internal hard disk. Required patterns are saved to memory to output various modulation signals simply by selecting from memory. Expanding the memory capacity to hold 256 megasamples, which is 4 times the general capacity, supports batch loading. The IQ Producer PC software generates waveform patterns for the vector signal generator option. Communication methods without standard waveform patterns, such as LTE and WiMAX, can be generated by IQ Producer. IQ Producer can be used as soon as the license is installed in the MS2830A. The MS2830A is a multi-function spectrum analyzer platform that's easily expanded by adding options supporting a wide range of measurement solutions. It's the ideal instrument for your evaluation environment.